So now in this video we're going to take a look at finding higher order derivative of a function whose derivatives will go on indefinitely. So we'll start off with y equals 1 plus x, and it might be helpful to note that we can write the 1 plus x as a power to negative 1, as 1 plus x all to the power of negative 1. And we're going to try to find if there's a pattern to the derivatives as we go on from the first derivative to the second derivative and so on. So the first derivative, this is a chain rule. We have a parentheses to a power, so this is like the general power rule with the chain rule. We have negative 1, 1 plus x to the negative 1 minus 1, which is minus 2. We have the second derivative. We apply negative 1 times negative 2. And I'm not going to simplify them because I want you to see the pattern here. So negative 1 times negative 2, parentheses 1 plus x to the minus 3 power. So that's the second derivative. The third derivative is negative 1 times negative 2 times negative 3. So I kept what I had from the second derivative, negative 1, negative 2. And then the negative 3 came from my exponent. And then 1 plus x to the negative 4. I think you're getting the pattern, but let me go one more in case. Negative 1 times negative 2 times negative 3. That's a little sad. Times negative 4 to the power, or sorry, times 1 plus x to the power negative 5. Okay, we could go on. And rather than doing this forever, because you can see this is not going to vanish to 0 like some of the polynomials we saw before, but we can find a general rule for the nth derivative, and that would be negative 1 times negative 2 times negative 3, and so on, times parentheses 1 plus x. Now if you notice, this was always, so there's the fourth derivative is minus 5, third derivative is minus 4, second derivative is minus 3. Nth derivative, it's going to be minus 1 more, minus the parentheses, n plus 1. So, it's like minus, and then that number is just 1 bigger than our derivative. So there's a special name, in fact, for, well, before I do that, let me say I'm going to factor out, I forgot, there's a missing, negative 1 times negative 2 times negative 3. You stop counting, there's a negative n in here. Sorry about that. So it's negative 1 times negative 2 times negative 3 times negative n, because we went from negative 1 to negative 4. We're doing the fourth derivative. We went from negative 1 to negative 3 with the third derivative. So we're going from negative 1 to negative n for the nth derivative. So there are n negative 1's in here. That's negative 1 to the nth power. Then times 1 times 2 times 3 times dot 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 times n, and then 1 plus x to the minus n plus 1. Okay, now, this is what I wanted to say before. This 1 times 2 times 3 times dot 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 all the way up to n, that has a special name. That's n factorial, n with an exclamation mark. It doesn't mean shout n. It just means we're going to start with n and count down, or we can start at 1 and count up to n. Let me give you a quick aside over here. 3 factorial is 3 times 2 times 1, or we could write it 1 times 2 times 3. And we're using the 1 times 2 times 3 format over here. Okay, so now we've got this in a pretty tight formula. Negative 1 to the n times n factorial times 1 plus x to the negative n plus 1. that's our general nth derivative of the function 1 over 1 plus x. And in Calc 2, this will be an important technique for something called the power series. And actually, this is a power series, but that's for another video.